So I'm going to go through the angles and polygons test which I set you. You'll probably notice I had this question twice, so I took it out at the final mark rather than having you get marked twice for it. Polygon ABCDEF may be divided into triangles. One triangle is shown. Use a triangle to work the sum of the interior angles of the polygon ABCDEF. Okay, so if I do that, I can draw another one going there, and another one going here. So you have 1, 2, 3, 4 triangles. Now if a triangle has 180 degrees, 4 triangles will have 4 times 180 degrees. And that is 720. Okay. Now some people would have only got 1 mark because the question's asking you for the sum of the interior angles. It's not asking for the size of each one. If you then divided your answer by 6, you would have got the answer wrong. Okay, and you would have lost a mark. Calculate the sum of the interior angles again, so just what the angles add up to rather than the size of each one. So we would use the formula n minus 2 times by 180. Okay, so the number of sides is 8, so that becomes 6 times 180. And that was 1080. Is it possible to have a regular polygon with an interior angle of 130 degrees? Well, for this question, what I would do is I would try and find the exterior angle, okay? Now we know that if polygon's going around like that, the exterior angle will be this one here. So if this is 130, the exterior must be 50, okay? So if the exterior angle was 50 degrees, how many sides would there be? Well, it would be 360 divided by 50, which gave you an answer of 7.2. You cannot get 7.2 sides in a shape. You can't have 0.2. So because of that, it is not possible. So the answer was no. Okay. If you said no, without that explanation, you wouldn't get any marks at all. You have to explain it. Okay, using maths. Calculate the size of angle X. Okay, so we have 4 angles here. We've got the 160, 115 and 290s. So let's add them all up together. So 160 plus 115 plus 90 plus 90. So if I add that up, I get 160 plus 115 plus 90 plus 90 gives me 455. Most of you were able to figure out that this the angles in a pentagon adds up to 540. That's just n minus 2 times 180, which is 3 times 180, which gives 540. We take our 2 answers away from each other, so 540 and 455, and that gives me an answer of 85 degrees. Moving on. Shown is an interior angle from a regular polygon. Calculate the number of sides. So for number of sides, I normally think exterior angles. So if that's 175, the exterior must be 5 degrees because it's a straight line. How many exterior angles are there? Well, that would be 360 divided by 5, which is 72. So if there's 72 exterior angles, there must be 72 sides. So that's the answer to question 4. And question 5, calculate the number of sides each of these regular polygons has. So this one and this one. Right, so number of sides, I straight away think exterior angles. So if this is a regular polygon, it basically means that this side's the same and this side's the same, okay? Which is going to end up giving us an equilateral triangle. Okay, so that must be 60. Okay, I'm going to zoom a wee bit. Now, if we think of this as the exterior angle, if the whole angle is 60, half the angle must be 30 degrees. Okay, so the exterior angle is 30 degrees. How many 30 degrees are there in 360? Because the exterior angles add up to that. We do 360 divided by 30, which gives us 12. So there were 12 sides. And that is that test worked through, guys. Okay? Hope that helps. See you now.